Walking down the sidewalk, you see thousands of gallons of treated drinking water violently exploding out of a fire hydrant and straight into the gutter. In an era of increasing droughts and strict conservation rules, this appearance of waste is frustrating. We are constantly told to shorten our showers and limit lawn watering, while the city seems to be throwing away a massive public resource. It floods streets, creates environmental runoff hazards, and can cause your home's topwater to temporarily turn a concerning shade of brown. This planned discharge is a highly engineered, legally mandated practice known as a flushing program. Neglecting this process allows water to stagnate until its chemical disinfection fails, while the physical hardware risks seizing up during a life-threatening fire. To understand how the system is flushed, we first have to understand the street-level release valves used to access the water. In warm climates, cities use what is called a wet barrel hydrant. These hold water inside the above-ground iron body at all times, giving emergency crews instant flow the second they open the valve. However, in areas that experience freezing temperatures, keeping water above ground would cause the iron casing to turn into ice and crack. These regions rely on a dry barrel hydrant. The actual water valve for a dry barrel is buried deep underground, resting safely beneath the frost line. The visible iron structure you see on the sidewalk is kept completely empty. To operate it, a worker must insert a long rod down through the empty barrel to manually turn the subterranean valve, which finally allows water to rush up to the surface. Successfully maintaining the massive invisible infrastructure beneath the street starts with managing these varied above-ground valves. Between 60 and 70% of a city's total water utility investment consists of these sprawling underground main lines, buried entirely out of sight. Looking at this cross-section of a pipe network, you can see how water flowing through the grid eventually slows down and stops at dead-end pipes. This creates a condition known as water age, where the water becomes completely stagnant. Inside these stagnant zones, biofilm and sediment rapidly build up on the pipe walls. As the grime accumulates, the essential chlorine used to keep the water disinfected rapidly drops. There is a serious mechanical risk here too. If the physical valves and hydrants are not regularly exercised with flowing water, the internal mechanisms can seize up and fail exactly when they are needed most. The subterranean pipe network acts remarkably like a human circulatory system. When it develops the structural equivalent of arterial plaque, it requires a deliberate, high-pressure medical intervention to cure it. For decades, the primary solution was conventional flushing, which meant sending a crew to simply crank open a street hydrant in response to a customer complaint. This overhead map illustrates the mechanical flaw of the conventional method. Opening a single point pulls water from multiple directions at once, wasting water without ever generating enough force to scour the interior pipes. Modern utilities utilize a highly engineered approach called unidirectional flushing. Workers follow a strict sequence, closing specific street valves to isolate a single continuous pipeline. Restricting the path forces the water to travel at a high velocity of 2 to 5 feet per second. This concentrated flow, acting like a pressure washer, blasts the sediment and biofilm completely off the pipe walls. Because this targeted scouring happens so rapidly and effectively, it actually uses 40% less water than the chaotic conventional method. Unidirectional flushing takes an action that looks like a blunt waste of water and turns it into a precise, resource-saving tool for municipal hygiene. If you see a city crew flushing hydrants on your street, do not run your dishwasher, do laundry, or flush your toilets. Running water inside the house during an active flush will draw the disturbed, high-velocity sediment straight from the street main into your home's private pipes and appliances. You also do not need to worry about environmental damage. Modern crews run the discharged water through specialized equipment filled with neutralizing agents, ensuring the heavy chlorine dissipates before the runoff hits local fish habitats. The next time you see thousands of gallons rushing out of a hydrant, you can view the situation differently. You are listening to the loud, rushing sound of preventative maintenance. This routine flush guarantees that emergency crews have the pressure they need to save lives, and your tap consistently delivers clean, safe drinking water.